Vulcan Foundation Equipment Repair Welding Procedure VFE RW-3 for ductile iron. Item 1, Scope. This procedure covers the repair welding of pearlitic and ferritic ductile or nodular iron. The corresponding base material specifications are VIWI, MS1, or equivalent. Section 2, Defect Removal. The defect may be removed by chipping, grinding or machining. While carbon arc may be used on ductile iron, it is not recommended due to thermal shock in the formation of carbide martensite structure on the surface of the cavity. It is important that the weld cavity consist of sound, clean metal. In critical areas, the use of magnetic particle or dye penetrant inspection is strongly recommended. Section 3, Preheat Temperature. The preheat temperature is 550 Fahrenheit or 290 Celsius. Preheating should be done in a temperature-controlled furnace. Begin heating the part at 100 Fahrenheit or 40 Celsius, holding 1 hour per inch or 25 minutes per centimeter of metal section for 6 hours maximum. Raise the temperature 100 Fahrenheit or 40 Celsius per hour to 550 Fahrenheit or 290 Celsius. Hold 1 hour per inch or 25 minutes per centimeter or 6 hours maximum. Localized preheating may be used when furnaces are not available. The following precautions should be observed. Item 1. The area preheated must be at least 2 feet or 60 centimeters from the edge of the weld cavity. Castings more than 6 inches or 15 centimeters thick should be preheated at least 3 feet or 90 centimeters from the cavity. Item 2. Heating must be done slowly and evenly. Temperature gradients of more than 100 Fahrenheit or 40 Celsius should be avoided. Item 3. The temperature must be uniform throughout the section preheated. Holding times of 1 hour per inch or 25 minutes per centimeter of metal section should be observed. Section 4. Interpass Temperature. The interpass temperature is 700 Fahrenheit or 370 Celsius maximum. When practical 600 Fahrenheit or 320 Celsius should be used, but in no case exceed 700 Fahrenheit or 320 Celsius. Section 5, Welding Parameters. The shielded metal arc welding process SMAW should be used for all welding. Welding current. Direct current, reverse polarity DCRP is required for the electrodes recommended. The voltage and amperage settings should be based on the recommendations of the electrode manufacturer. Electrodes. 2 electrodes are recommended. The first produces a machine-able weld deposit and a lower hardness in the heat-affected zone HAZ. The second electrode produces a higher strength weld but may be difficult to machine. Greater care is also required in welding with the second electrode to prevent cracking in the fusion zone. Option 1. AWS, ENIFECI. This is a 55% nickel electrode having a weld strength of about 50,000 psi or 345 MPa tensile strength. It requires a lower amperage and less heat input. It melts at lower temperature than carbon steel electrodes, therefore, creates less carbide martensite in the HAZ. Option 2. AWS, E7018, E7016, or E7015. This is a carbon steel electrode with a higher strength as deposited, 70,000 psi or 485 MPa maximum tensile. It requires a higher amperage, more heat input, and is more susceptible to cracking. As with all low hydrogen electrodes, they should be stored in a warm, dry compartment after the cans are opened. Section 6, Technique. The weld bead should be of stringer type. The arc should be struck on the weld deposit whenever possible. The slag should be removed from the weld deposit between each pass by chipping, pinning and wire brushing. Section 7, Post-welding heat treatment. All ductile iron castings should receive a post-welding heat treatment. Material poured to specification VIWI, MS1 Grade 1 need only be stress-relieved, while VIWI, MS1, Grades 2 and 3 material should be normalized and tempered. The recommended heat treatments are as follows. Grade 1. Place in a furnace at 200 Fahrenheit or 95 Celsius and soak for 1 hour per inch or 25 minutes per centimeter, 6 hours maximum. Heat slowly at 100 Fahrenheit per hour or 40 Celsius per hour to 1100 Fahrenheit 600 Celsius and hold 1 hour per inch or 25 minutes per centimeter, 6 hours maximum. Cool in still air. Grades 2 and 3. Place in a furnace at 200 Fahrenheit or 95 Celsius and soak for 1 hour per inch or 25 minutes per centimeter, 6 hours maximum. Heat slowly at 100 Fahrenheit or 40 Celsius per hour to 1000 Fahrenheit or 540 Celsius and 200 Fahrenheit per hour or 95 Celsius per HR to 1650 Fahrenheit or 900 Celsius. Hold 1 hour per inch or 25 minutes per centimeter, 6 hours maximum. Cool in still air. When the temperature of the casting is below 600 Fahrenheit or 320 Celsius, it may be placed into a tempering furnace, soaked at 600 Fahrenheit or 320 Celsius for 1 hour per inch or 25 minutes per centimeter, 6 hours maximum, and heated slowly 200 Fahrenheit per hour or 95 Celsius per hour to 1200 Fahrenheit or 650 Celsius. Hold at temperature for 1 hour per inch, 25 minutes per centimeter, 6 hours maximum, and cool in still air. Section 8, Precautions. The welding of ductile iron presents two problems. Concern 1. The base metal when melted at the fusion zone will not re-solidify as ductile iron, the graphite will precipitate as vermicular or quasi-nodular. The ductility and impact resistance will be reduced about 50%, and some carbides are likely to form, particularly in the perlite grade. Concern 2. The HAZ will produce a martensite, especially in the perlite grade, which must be tempered to restore any ductility. Ductile iron is more susceptible to welding stresses, and more likely to crack while welding or during cooling. Therefore, ductile iron should never be welded in highly stressed parts or areas. Welds should never be made when the weld is more than 20% of the metal thickness. See also the section on general considerations for more information. Please visit the Vulcan Foundation website at www.vulcanhammer.com. Vulcan Foundation Equipment, 111 Berry Road, P.O. Box 16099, Houston, Texas 77222. Phone, 713-695-4000. Fax, 713-691-0089.